A battery produces electricity by transforming chemical energy inside the battery into electrical energy. And the purpose of a battery is to produce a potential difference or a voltage that can make charges move. There's a continuous flow of electrons throughout the wire that begins as soon as you hook a battery up to it. And that flow of charge is called current, which is designated by the letter I, and it's given by the equation I is equal to Q over T, where Q is the charge that passes through a point in a given time T. The standard unit for current is the ampere, A-M-P-E-R-E. It's abbreviated by a capital A, and 1 ampere is equal to, if you look at this equation, it's coulombs, that charge is in coulombs, time is in seconds, so 1 ampere is the same as 1 coulomb per second. Current can only flow around a complete loop, which is called a closed circuit. If there's any kind of break in the loop or gap in the loop, it's called an open circuit, and charges are unable to flow. So that's the purpose of a switch. The switch is just used to trigger back and forth between an open and a closed circuit. Conventional current is defined as the flow of positive charge, but it's the electrons that have negative charge that actually move in a wire. So let's say you have this wire. So this is just going to represent a wire, and let's say the current is flowing in the wire in that direction, so we can say that's the direction of the current. The electrons are actually moving in the opposite direction, so the electrons are moving that way. So that's that last blank in that paragraph. Positive charge flowing in one direction is equivalent to negative charge or electrons flowing in the opposite direction. So an example 15.1. We've got a steady current of 2 amps exists in a wire for 5 minutes. How many electrons pass a given point in the wire during that time? First thing is to get things in standard units. 5 minutes is the equivalent of 300 seconds. Now we'll take this I equals Q over T equation and rearrange it for charge. So Q is equal to I times T. The current was 2 amps times the time of 300 seconds. So the total charge that passes is 600 coulombs. So if it's 600 coulombs, you want to figure out how many electrons that is. You just divide that 600 coulombs by the charge of 1 electron. So 600 divided by 1.6 times 10 to the negative 19, which gives you a total amount of electrons of 3.7 times 10 to the 21. So a resistor is a device that controls the amount of current in a circuit by offering a resistance. The filaments of light bulbs and electric heaters, they use special types of resistors that become really hot to the point where they start glowing. The resistance of a resistor is designated by R, and the equation for it is R is equal to, it's the Greek letter rho, the same letter we use for density, L over A. And in that equation, the L is the length of the resistor and A is the cross-sectional area. The rho is a thing called resistivity. This is something that depends on what the resistor is made out of. So don't get resistivity mixed up with resistance. Resistivity is a fixed value for different materials, but the resistance depends on the resistivity. The standard unit for resistance is the ohm. That's OHM. And the symbol for ohm is the Greek letter omega, which looks kind of like a horseshoe. Conductors, things like metals, have very low resistivities because they don't resist the current that much. It's easy for electrons to flow through them. So for example, copper has a resistivity of 1.68 times 10 to the negative 8, But inductors, where electrons cannot flow easy, have really high resistivities. So like glass, for example, is between 10 to the 12th and 10 to the 15th power, depending on what type of glass it is. Example 15.2. To use that equation to determine the unit of resistivity. So if we just take this equation and rearrange it for rho, we're going to multiply both sides by A and divide by L, so rho is equal to RA over L. Resistance is units of ohms, area is meters squared, and length is meters. One of the meters will cancel out, and it leaves you with units of ohm meters.